Here's what mechanics will never tell you when you're shopping for cars. What if I told you that 78% of car owners face major engine failure before 200,000 miles? That's not a coincidence. 78% suffer because they bought cars without understanding basic longevity principles. Picture yourself excited about your reliable transportation, only to end up facing a $15,000 engine replacement that could have been completely avoided. In this video, I'm revealing the 12 most powerful longevity habits for 2025 that actually let you drive past 300,000 miles. And trust me, number 1 will surprise you. It's a choice that costs nothing but determines everything about your car's lifespan. Stay until the end because this isn't just entertainment. It's your guide to avoiding the expensive mistake that kills most people's automotive dreams. Number 12, minimize idling. Modern cars don't need long warm-ups. Let's destroy the biggest myth in car care that's costing you thousands. That long warm-up you're giving your car every morning, it's actually killing your engine faster than driving it hard on the highway. The traditional practice of prolonged car warm-ups comes from the era of carbureted engines, but it's completely unnecessary and often detrimental for modern fuel-injected vehicles. Modern engines are designed to achieve optimal lubrication within just 30 seconds of starting, not the 5 to 10 minutes many owners think they need. Here's the brutal truth about excessive idling. Idling for more than 10 to 30 seconds consumes more fuel than turning off the engine and restarting it. A vehicle idling for just 2 minutes uses the same amount of fuel required to drive 1 mile. Every hour of accumulated idle time consumes an entire gallon of fuel while achieving 0 miles per gallon. But fuel waste is nothing compared to the engine damage you're causing. Excessive idling actually damages engine components including cylinders, spark plugs, and exhaust systems. During cold warm-up, the extra fuel pumped into the engine washes off the lubricating oil from cylinder walls, causing accelerated engine wear that builds up over time. For diesel engines, the damage is even more severe. Prolonged idling leads to incomplete combustion, resulting in carbon buildup and unburned fuel diluting the engine oil. This contamination increases wear and tear on engine components significantly, potentially shortening engine life by tens of thousands of miles. The chemical attack reveals why cold idling is so destructive to your investment. When engines don't reach their optimal operating temperature, moisture, blow-by soot, and raw gasoline accumulate in the engine oil. This contamination breaks down the oil faster and forms thick sludge that clogs oil passages and reduces lubrication effectiveness where you need it most. Personal use vehicles alone generate about 30 million tons of carbon dioxide annually from idling in the US, while also releasing nitrogen oxides and volatile organic compounds into the atmosphere. You're literally burning money while poisoning the air. The solution is simple but requires breaking old habits. Start driving gently within 30 seconds of ignition. For extremely cold conditions, idle for a maximum of 2 minutes before driving off gently. Avoid high speeds or rapid acceleration until the engine is fully warmed. This approach minimizes fuel waste, reduces harmful emissions, and allows the engine to reach optimal operating temperature efficiently. Number 11, drive smoothly, gentle acceleration and braking. Your driving style is either building your car's longevity foundation or destroying it with every single mile you drive. Most drivers don't realize that rapid acceleration and hard braking impose excessive strain on the engine, transmission, drivetrain, and braking components, leading to premature wear that substantially shortens component lifespan. Smooth and gradual acceleration allows the engine to operate more efficiently, minimizing stress on components like the timing belt and fuel system, while contributing to significantly better fuel economy. You're not just saving gas money, you're saving thousands in future repairs. Gentle braking avoids excessive heat buildup that rapidly degrades brake components, reduces stress on brake pads and rotors, conserves fuel through better energy management, and lessens overall wear on the braking system, transmission, and engine. The impact of driving style extends far beyond individual components to affect the entire vehicle system as one interconnected machine. Aggressive driving introduces higher dynamic stresses across interconnected mechanical and powertrain systems. When you floor the accelerator, you're forcing the engine to work much harder, leading to higher operating temperatures and accelerated wear throughout the system. This increased strain also translates directly to the transmission, which must suddenly manage massive torque demands it wasn't designed to handle repeatedly. Hard braking generates excessive heat that rapidly degrades brake pads and rotors. But the sudden shifts in momentum during aggressive braking also impact the vehicle's suspension system and transmission in ways most drivers never consider. The hidden cost of aggressive driving is that it reduces systemic longevity across the entire vehicle, creating a domino effect of premature failures throughout complex automotive systems. When one component fails early due to abuse, it often causes cascading problems in related systems. Driving smoothly reduces this systemic stress across your entire vehicle, preventing the domino effect of premature failures that can cost thousands in unexpected repairs. Anticipating stops and coasting whenever possible significantly extends brake component life while reducing fuel consumption. Maintaining steady speeds and avoiding jackrabbit starts protects your engine, transmission, and entire drivetrain from unnecessary stress that accumulates over thousands of miles. Number 10. Avoid engine lugging, the silent killer. Engine lugging occurs when you operate with significant throttle at very low RPMs, often in higher gears than appropriate for current speed. You'll know you're lugging when engines struggle, vibrate, shake, or emit growling noises with poor accelerator response. When pressing throttle during lugging, large fuel and air volumes enter cylinders. Because engines operate at low RPMs, cylinder pressure drastically increases, making piston movement difficult and causing premature combustion with audible knocking. This chips metal fragments off cylinders, spark plugs, and exhaust systems. The critical vulnerability lies in bearings. Lugging places high loads precisely when they receive insufficient oil pressure. Oil pumps are crankshaft-driven, so low RPMs mean slow pumps and reduced pressure. This combination of high load and low pressure breaks down protective oil films, causing increased friction, scoring, and bearing failure that rebuilders describe as toasting the bearings. For turbocharged engines, turbochargers force pressurized air into cylinders, effectively doubling excessive pressure and potentially damaging engines and turbochargers simultaneously. Prevention is straightforward. Downshift to increase RPMs. Maintain 1500 to 2500 RPMs, typically above 2000 for most conditions, ensuring engines operate in optimal power bands with adequate lubrication pressure. Number 9. Keep all fluids optimal, beyond just oil. Your car relies on multiple fluids serving vital purposes. Neglecting any leads to cascading failures that can destroy expensive components. Coolant manages engine heat with combustion generating 2000-degree temperatures and spikes to 4500 degrees. Aluminum parts melt at 1225 degrees, making cooling critical. Neglecting coolant causes warped heads, blown gaskets, and complete failure. Flush every 2 years or 30,000 miles for extended drain. Warning signs include sweet smells from under the hood, gurgling noises upon starting, overheating with temperature gauges in red zones, and visible green, orange, or pink leaks. Transmission fluid functions as hydraulic fluid, lubricant, and coolant. Change manual transmission fluid every 30,000 to 60,000 miles. Automatics every 60,000 to 100,000 miles. Heavy-duty use requires more frequent changes. Degraded fluid shows color changes from red to brown or black, burning smells, slipping gears, delayed shifting, grinding noises, and unexpected RPM surges. Neglecting changes leads to accelerated wear, overheating, and costly major repairs. Brake fluid transmits hydraulic pressure, but degrades by absorbing moisture, lowering boiling points and creating vapor bubbles under heavy braking. This causes spongy, unresponsive pedals that compromise safety. Power steering fluid enables easy steering. Low levels cause loud noises, stiff steering, or lock wheels, creating safety hazards. These degradation processes happen continuously, even when vehicles run perfectly. Proactive maintenance prevents wear rather than reacting to failure. Number 8. Ensure clean air and fuel, your engine's essential filters. Filters protect critical systems from contaminants. The engine air filter prevents dirt, dust, and particles from entering combustion chambers. Even salt grain-sized particles damage cylinders and pistons, causing expensive repairs. Replace every 12,000 to 15,000 miles, more frequently in dusty conditions. Clogged filters cause sluggish acceleration, misfiring, black smoke, service engine lights, and reduced power rather than directly impacting fuel economy in modern vehicles. Modern fuel-injected engines automatically adjust air-fuel mixtures based on airflow. Dirty filters primarily reduce maximum horsepower and torque, making cars feel slower rather than less efficient. Cabin filters purify passenger air, trapping dust, pollen, mold spores, and odors. Replace every 12,000 to 30,000 miles, or when experiencing reduced airflow, musty odors, increased allergies, or fogging windows. Fuel filters clean impurities before reaching injection systems. Replacement intervals range from 12,000 to 70,000 miles depending on vehicle age. Clogged filters restrict flow, forcing pumps to work harder and potentially causing engine failure. Symptoms include difficulty starting, stalling, rough idling, poor acceleration, engine misfires, and reduced fuel efficiency. For heavy-duty towing or dusty conditions, have recommended intervals. Before we reveal the top 7 habits that separate 300,000-mile cars from early failures, take a moment to subscribe. You'll get more content like this that saves you thousands in repair bills and keeps your car running strong for decades. Number 7. Master your oil changes, the engine's lifeblood. Regular oil changes are universally recognized as the absolute cornerstone of engine maintenance, yet most car owners fundamentally misunderstand when and why they need to change their oil. Engine oil performs multiple absolutely critical functions that keep your engine alive: lubricating moving parts to reduce friction and prevent seizure, dissipating dangerous heat from combustion zones, carrying away harmful contaminants before they can cause damage, and preventing destructive rust formation within the engine's internal components. Without proper lubrication from clean oil, your engine's moving components would literally grind against each other at thousands of RPMs, leading to rapid and catastrophically expensive damage that can destroy an engine in minutes of operation. The consequences of neglecting oil changes are severe and build progressively over time. Engine oil breaks down chemically through exposure to heat and contamination, losing its critical protective effectiveness while becoming contaminated with dirt, metallic debris from normal wear, and thick sludge formed by chemical breakdown. This degradation results in dramatically increased friction between moving parts, dangerous localized overheating that can warp components, and severely accelerated wear on absolutely vital engine parts, including bearings, pistons, and camshafts. In extreme cases of neglect, thick sludge buildup can completely clog critical oil passages, literally starving your engine of lubrication and leading to complete engine failure that requires full replacements, costing thousands. Modern vehicles utilizing advanced synthetic or semi-synthetic oils have significantly extended oil change intervals, often ranging from 7,500 to 10,000 miles or even more under ideal conditions. This represents a notable departure from the outdated 3,000-mile guideline that many people still follow unnecessarily. Conventional oil typically requires changes every 3,000 to 5,000 miles due to its faster chemical breakdown rate, while synthetic blends generally extend service intervals to 5,000 to 7,500 miles. Full synthetic oil offers superior protection against high temperatures, oxidation, and sludge formation, contributing to longer engine life and extended service intervals. However, your actual driving conditions play an absolutely crucial role in determining the real frequency required for your specific situation. Severe service conditions include frequent short trips where the engine never reaches optimal operating temperature, heavy stop-and-go traffic that prevents proper engine operation, prolonged idling that causes incomplete combustion, towing heavy loads that stress the engine, or operating in dusty environments or extremely hot or cold temperatures. Under these severe conditions, oil change intervals might need to revert to as frequently as 3,000 miles for conventional oil, 5,000 to 7,500 miles for synthetic blends, and 7,500 to 10,000 miles for full synthetic oils to prevent accelerated engine wear. Even if your vehicle isn't driven regularly, oil still degrades over time due to chemical processes that occur regardless of mileage accumulation, which means oil should be changed at least every 6 to 12 months, regardless of how many miles you've driven. Number 6. Follow your car's maintenance schedule. Manufacturer-recommended schedules are meticulously designed for each system, preventing minor issues from becoming costly damage. Schedules are custom-tailored to specific models considering design and operating conditions. Many use 30-60-90 schedules for essential maintenance at 30,000, 60,000, and 90,000 miles. Modern vehicles feature sophisticated monitoring systems analyzing real-time conditions, including temperature, revolutions, and driving habits. These systems actively assess wear and tear, providing optimized timing by accounting for individual styles and environmental factors. This means trusting alerts and understanding that seemingly normal driving might classify as severe service, depending on usage patterns. Maintenance is becoming dynamic, responding to real-time conditions rather than rigid intervals. Understanding nuanced impacts of factors like fluid degradation, engine lugging, and short trips is paramount for achieving ultra-high mileage. Consistent adherence combined with understanding reasoning transforms maintenance from reactive chores into strategic longevity investments that protect your automotive investment. Number 5. Protect against road hazards. Roads pose constant threats requiring awareness and caution. Potholes and bumps damage multiple systems simultaneously, affecting suspension components like shock absorbers, struts, springs, and control arms. Research shows drastic reductions in spring fatigue on rough roads compared to smooth surfaces. Impacts cause steering misalignment, affecting handling while accelerating tire wear. Tires and wheels suffer uneven wear, punctures, sidewall damage, and bent rims. Modern vehicles with driver assistance systems require expensive recalibration after damage, adding hundreds to repair costs. Prevention requires proactive driving. Continuously scan ahead for hazards and steer around safely. When unavoidable, reduce speed significantly and avoid abrupt braking over hazards. Maintain proper tire pressure as first defense against impacts. Speed bumps and debris pose similar threats. Approach bumps slowly and avoid debris when safely possible. Construction zones require extra vigilance due to uneven surfaces, loose materials, and changing road conditions that can damage undercarriage components. Number 4. Maintain optimal tire pressure and alignment. Tires are your only road connection, yet most drivers ignore them until failure. Underinflated tires increase rolling resistance, forcing engines to work harder and decreasing mileage by 0.2% per psi drop across all tires. Underinflation causes uneven wear, reducing life by 10% per psi lost, while compromising handling, stability, and braking, while increasing dangerous blowout risks. Overinflation can improve efficiency slightly, but negatively impacts handling and braking. Check pressure monthly when cold using manufacturer recommendations from door jamb stickers, not tire sidewalls, which show maximum ratings rather than optimal operating pressures. Misaligned wheels cause uneven wear, increased resistance forcing engines to work harder, reduced efficiency up to 10%, vehicle pulling, vibrating steering, and suspension strain that accelerates component wear. Check alignment annually or every 10,000 to 15,000 miles, or when symptoms appear. Rotate tires every 5,000 to 8,000 miles for even wear distribution. Proper maintenance protects interconnected systems from premature wear and costly repairs. Number 3. Monitor and respond to warning lights. Dashboard lights are emergency communication systems. Ignoring them transforms minor fixes into major disasters that can cost thousands. Check engine lights indicate control system problems, ranging from loose gas caps to engine malfunctions. Blinking lights signal critical issues needing immediate attention. Simple $10 to $50 fixes become $1,000 to $3,000 catalytic converter replacements when ignored. Oil pressure lights indicate low pressure, insufficient levels, or excessive heat. Ignoring causes severe damage within minutes, as bearings seize and cylinders score without adequate lubrication. Brake lights signal fluid issues, worn pads, or system malfunctions. Changes in performance warrant immediate investigation for safety, since brake failure can cause accidents. Coolant temperature lights indicate unsafe temperatures. Ignoring causes rapid overheating and irreparable damage, including warped heads, blown gaskets, and cracked blocks requiring engine replacement. Warning lights get ignored because cars seem fine. Computer systems compensate for problems, masking symptoms while damage progresses. This creates false security until problems compound into expensive issues. Modern diagnostic tools provide precise identification rather than guesswork, ensuring accurate repairs and preventing small issues from becoming major failures that destroy engines. Number 2, prevent short trip damage. Frequent short trips where engines don't reach optimal temperature are highly detrimental. Condensation and combustion byproducts don't evaporate, mixing with oil to form thick sludge that clogs passages and increases friction, accelerating wear on bearings and piston rings. Cold engines operate with looser tolerances, increasing wear between components. Extra fuel injected into cold engines washes protective oil films off cylinder walls, while inefficient burning causes carbon buildup throughout engines and exhaust systems. The chemical attack reveals why short trips are destructive. Moisture, blow-by soot, and raw gasoline accumulate when engines don't reach full temperature, breaking down oil faster and compromising lubrication effectiveness. Short trips affect batteries as alternators don't run long enough for full recharging, reducing capacity and lifespan. Stop-and-go traffic causes uneven tire wear patterns. Emission systems suffer as catalytic converters require high temperatures for effective operation. When they don't reach optimal temperatures, they can't process emissions properly, leading to pollution and potential system damage. Consolidate errands into longer trips when possible. Take periodic longer drives, allowing engines to reach and maintain optimal temperature, burning off contaminants while fully recharging batteries. Use battery tenders for unavoidable short trips, and maintain more frequent oil changes for vehicles primarily used for short distances. Number 1, choose the right powertrain foundation. The single most important decision for achieving 300,000+ mile longevity isn't actually a maintenance habit at all. It's making the right foundational powertrain choice before you even start your ownership journey. This crucial initial decision determines your vehicle's inherent longevity potential more than any other single factor, including how well you maintain it afterward. While the average gasoline car engine typically lasts between 150,000 to 200,000 miles with reasonable care, diesel engines inherently offer dramatically greater potential lifespans, often ranging from 400,000 to 1 million miles or more. This exceptional extended durability comes directly from their fundamentally different and more robust design philosophy, featuring heavy-duty internal components and an inherent ability to operate efficiently under much higher pressure and temperature conditions than gasoline engines. Electric vehicles are rapidly emerging as serious longevity contenders in the modern automotive landscape, with their advanced battery systems reportedly lasting well over 400,000 miles, and ongoing technological improvements promising even longer operational lifespans, potentially reaching 1 million miles or more. The advanced battery technology and highly efficient electric motors in these vehicles allow optimal operation even in extreme cold weather conditions, without requiring traditional warm-up periods that can damage conventional engines. The automotive longevity landscape is continually evolving, driven by rapid advancements in automotive engineering, materials science, and manufacturing techniques. While all the maintenance habits we've discussed are universally beneficial for extending the life of any vehicle type, starting with a powertrain that's specifically designed for inherent durability provides a much stronger foundation for achieving ultra-high mileage goals. Diesel engines feature fundamentally larger and stronger internal components, including oversized crankshafts, camshafts, forged steel crankshafts, and heavy-duty cast-iron engine blocks, specifically engineered and built to withstand the dramatically higher compression ratios and internal pressures inherent in diesel combustion cycles. They're literally engineered from the ground up, with longevity as a primary design objective rather than an afterthought. Electric vehicles eliminate many of the wear-prone mechanical components found in traditional internal combustion engines entirely. No oil changes, no transmission fluid maintenance, no spark plug replacements, no timing belt services, and dramatically fewer moving parts overall. Fewer moving components directly translates to fewer potential failure points and substantially reduced ongoing maintenance requirements over the vehicle's lifetime. For gasoline engines, certain specific designs and particular manufacturers have demonstrated consistently superior longevity characteristics over decades of real-world testing. Toyota and Honda engines, particularly their naturally aspirated four-cylinder designs, consistently achieve exceptionally high mileage with proper care through their conservative engineering approaches over maximum performance output. Turbocharged engines, while offering excellent performance characteristics and fuel economy, typically require more frequent and expensive maintenance, while potentially having shorter overall lifespans due to their increased mechanical complexity and higher internal operating stresses compared to naturally aspirated designs. The key insight for longevity-focused buyers is that while proper maintenance habits can significantly extend any engine's operational life, starting with an inherently durable powertrain design provides the absolute best foundation for achieving exceptional longevity. This fundamental choice, combined with consistent application of the other 11 habits we've covered, maximizes your realistic chances of reaching 300,000 miles and well beyond. This highlights that fundamental engineering decisions and material choices made during vehicle design significantly influence the vehicle's inherent long-term potential, suggesting that the future of automotive longevity may shift the primary focus from reactive maintenance habits toward proactive powertrain selection for buyers who prioritize achieving exceptional durability and longevity from their automotive investments. These 12 habits separate 300,000-mile cars from early failures. But even perfect maintenance means nothing if you start with an unreliable truck. Some models are legendary for decades of trouble-free service. Check out our breakdown of 20 trucks so reliable you'll never regret buying them to discover the best foundation for these longevity habits.